Hello, I'm Brahmani from ECE. Today we are going to discuss about generation of Bessel's functions through generating function relation in signals processing. Introduction to Bessel functions in signal processing. Bessel functions are a family of solutions to Bessel's differential equation frequently used in engineering and physics. They appear naturally in problems with cylindrical or spherical symmetry, especially in signal processing. Understanding the generation through generating functions helps simplify complex signal analysis tasks. Overview of generating functions. Generating functions are mathematical tools that encode sequences into a single function. They facilitate the derivation and analysis of special functions like Bessel functions. In signal processing, generating functions aid in the analysis and design of systems involving Bessel functions. Overview of generating functions. Generating functions are mathematical tools that encode sequences into a single function. They facilitate the derivation and analysis of special functions like Bessel functions. In signal processing, generating functions aid in the analysis and design of systems involving Bessel functions. Definition of Bessel function of the first kind. Bessel functions of first kind are the solutions to Bessel differential equations that are infinite at the origin. They are particularly important in representing waveforms and oscillatory behavior. It can be expressed using series expansions, integral representations, and generating functions. The generating functions for Bessel functions, the fundamental generating function of Bessel function, and it is relation encodes all Bessel functions within a single exponential function. It enables the derivation of various properties and recurrence relations of Bessel functions. Derivation of Bessel functions from the generating function. By expanding the generating function in powers of individual Bessel functions can be extracted. Coefficients of the power series expansion correspond directly to the Bessel functions. This approach simplifies the process of obtaining Bessel functions for different orders. Connection to signal processing problems. Bessel functions appear in the analysis of modulating signals, especially in frequency modulation (FM). They are used to model the spectral content of signals, the cylindrical or spherical symmetry. Generating functions assist in analyzing these signals efficiently. Application in frequency modulation (FM). In FM, the signal can be expanded into Bessel function to understand in spectral components. The modulation index determines the amplitude of various Bessel function components. Generating functions simplify the derivation of these spectral components. Bessel function expansion in FM signals. It can be expressed as the sum evolving where beta is the modulation index. Expansion reveals the harmonic content of the modulated wave. Generating functions provide a systematic way to compute these coefficients. Recurrence relations from generating functions. Differentiating the generating function yields recurrence relations among Bessel functions. These relations are useful for recursive computation in signal processing algorithms. They also facilitate analysis of system responses involving Bessel functions. The Fourier series representation of Bessel function. The Bessel function can be represented as Fourier series derived from their generating functions. This representation aids in understanding their oscillatory behavior. It is particularly useful for analyzing periodic signals in signal processing. Numerical computation of Bessel functions. Generating function relations enable efficient numerical algorithms for computing Bessel functions. These algorithms are important for real-time signal processing applications. Stability and accuracy are enhanced by using generating function-based methods. Bessel function in antenna theory. Bessel functions describe radiation patterns of certain antennas with cylindrical symmetry. The generating function approach simplifies the analysis of these antenna patterns. Signal processing technique utilize these functions for designing and analyzing antenna systems. Bessel functions in filter design. Bessel functions are characterized by their linear phase response, crucial in signal processing. The transfer functions involve Bessel functions, which can be derived via generating functions. Understanding their generation assists in designing filters with desired phase characteristics. Time domain signal analysis using Bessel functions. Bessel function describe transient responses in system with cylindrical symmetry. Generating functions streamline the analysis of these responses. This approach improves the understanding of system dynamics in signal processing. Advantages of using generating functions. Generating functions provide a unified framework of deriving multiple properties of Bessel functions. They simplify complex calculations involved in signal analysis. This methodology enhances computational efficiency and analytical clarity. Limitations and challenges. Numerical instability can sometimes occur generating functions of large arguments. Analytical derivations may become complex for higher order Bessel functions. Careful application and numerical methods are required to accurate results. Recent advances in signal processing applications, new algorithms utilize generating functions for real time Bessel function computation. They enable improved modeling for complex modulating signals. Research continues to expand the applications of Bessel functions in modern signal processing. Summary of key concepts. Bessel functions are essential in analyzing cylindrical and spherical signals. Generating functions serve as powerful tools for deriving and computing these functions. Their applications span modulation, antenna theory, filter design, and system analysis. Future directions and research opportunities. Developing more stable and efficient numerical methods using generating functions, exploring higher dimensional applications in signal processing, integrating Bessel functions, and generating their functions into machine learning frameworks. Conclusion and references. The generation of Bessel function via generating functions is fundamental in signal processing. This approach enhances analytical understanding and computational efficiency. For further reading, consult keys and text on special function signal analysis and applied mathematics. This is about the Bessel function, advantages, time domain signal analysis, filter design, antenna theory, numerical computation, Fourier series representation, recurrence relations, and FM signals, and etc. Thank you.